Let's talk about the security concepts for hosting applications and clusters in Azure Kubernetes services. We deal with lots of sensitive data when hosting data in containers. There could be passwords, credentials, data at rest, and data in transit is what we are referring to, and both of them must be kept secure. By now, we know that there are two entities in Kubernetes that we are referring to. One is a master, and other is a node where your applications are hosted or containers are hosted. It's important that you go ahead and keep both of them secure because that is how you will protect your customers' data that is running the application workloads in the AKS clusters. In this lesson, we'll talk about the security of the master node, the node security, how do you handle the cluster upgrades moving from one version to another version, how do you handle the security for the data in transit with the help of network security, and finally, how do you handle the sensitive data in the pods? And it could be accessing credentials or certificates or keys with the help of Kubernetes secrets. So, how do we handle the master node security? We know that Kubernetes master components are part of managed service, and this is all managed and maintained by Microsoft. Every AKS cluster has its own single tenant, dedicated Kubernetes master, and it provides the API server, scheduler, internal DNS name resolution, etc. Hence, the security of it is also managed and maintained by Microsoft. By default, this Kubernetes API server will be using a public IP address and also a fully qualified domain name. If you integrate this with Azure Active Directory, you will be able to grant role-based access controls and granular permissioning using the Azure AD permissioning model. Let's talk about node security. These nodes host your applications in the pods. These nodes are all managed and maintained by you. They could be running on Windows operating system or it could be running on Linux operating system depending on the application that you have hosted. Their operating system security, updates, and configuration is all your responsibility. Microsoft Azure updates the operating system security patches to the Linux nodes on a nightly basis. But if a reboot is required, it is not done automatically. You need to perform the reboot yourself and you will get a notification for that. Every node is monitored for the latest security updates and those daemons are continuously monitored as well. Just like your master nodes, you can grant permissions to these nodes and even to the pods using role-based access controls and integrate that with Active Directory. Keep in mind that the security is for the entire cluster, including master and the nodes that you run your application. They are not for individual nodes. What about cluster upgrades? For security and compliance purposes, it's important to use the latest feature sets that are available in the AKS cluster. Azure provides the required tools to orchestrate the upgrade of an AKS cluster and its components. There have been different versions of Kubernetes in the past, and these upgrades keep on happening depends on how the cloud provider would like to manage it. It's important to have the Kubernetes version at the latest level. The upgrade orchestration includes both the Kubernetes master and the agent components. There is a process called as a cordon and drain process, and this is also called as an upgrade process, which works on the master and the agent nodes. Let's talk about the process of how these nodes are upgraded. So when a new node is deployed into a node pool, that node runs the latest operating system image and patches. One of the existing nodes is identified for the upgrade if the nodes are running at the older version. Pods on this node are gracefully terminated and scheduled on other nodes in the node pool. The node with the older operating system or older patches are deleted from the AKS cluster after the pods on it are gracefully terminated and moved to the other upgraded nodes. The next node in the cluster is cordoned and drained using the same process until all nodes are successfully replaced as part of the upgrade process. This ensures that all nodes are updated and upgraded at the same level. Network security, data in transit. Security for the data in transit is handled by network security. So you will have connectivity to your on-premise networks as well with your Azure AKS cluster. You may have site-to-site VPN or an express route which connects back to your on-premise networks. Kubernetes ingress controllers define how the connectivity should be. whether it should be private using internal IP addresses or should be accessible over the external networks as well. On top of it, you can use the Azure network security groups to write the rules and define the source, destination IP ranges, ports, and protocols that are allowed or denied access to the resources. Finally, the Kubernetes secrets is responsible for injecting the sensitive data into the pods on your nodes. The sensitive data can include credentials, keys, or anything that is secretive in nature or something that protects your information in the volumes. So when you create a secret, you will have the APIs and access keys connecting to the Kubernetes cluster so that the secrets can be requested for. Secrets are only provided to the nodes that have scheduled pod that requires it, and secrets are not written to the disk. They are accessed directly from the key vault and written to the temp storage or temp ephemeral volumes. And once the pod has accessed the secret and even the other pods do not need it, then that secret information is even deleted from those temporary folders. By using the secrets, you really do not have to store that information inside the pod or in the YAML files. Instead, you will be requesting for the secret information, which is stored on the Kubernetes API server on the master node as part of your YAML manifest. This approach ensures that the entire transaction is secure and the secrets are not exposed to unauthorized entities. It's a recommendation to never have the secrets committed to the source control or hard code the secret information in the YAML manifest.